Hello and welcome to the tutorial on the reactivity of alkenes and benzene. So if we have an alkene, cyclohexene plus bromine, we will get 1,2-dibromohexane. Now if you looked at previous tutorials, I used cyclohexene as an example for benzene, and Kekule was also used this example because it behaves similarly to benzene with the same sorts of chemical properties but not quite. So what's actually happening is the pi bonds here are overlapping and the double bond in this molecule is also causing an induced dipole. More on what induced dipoles are. I'm assuming that you already know what they are. If not, go to my tutorial in OCR-AS chemistry and find out about van der Waals forces. So the electron pair, as I've marked in blue, they lie towards one end of the bond, and this creates polarity. And the pi electron pair from the double bond is attracted to the slightly positive bromine atom, causing the double bond to break. And when the double bond forms between one of the carbon atoms and the bromine atom, it forms a positively charged carbocation, as I illustrate over here. Now, as any nucleophilic substitution reaction mechanism that you learned in AS chemistry, next that Br minus ion will bond to the carbocation as it is attracted to one another, and they will form a new bond with that spare electron in the shell. So step 1, it goes to form a slight electrostatic attraction, and then it forms an intermediate carbocation, and then it goes to form 1,2-dibromohexane. So the actual mechanism behind the use of the halogen carrier and why benzene needs it is explained here. So benzene is unable to react with bromine without the help of a halogen carrier catalyst. So I've said in previous tutorials that iron or iron bromate are required for any halogen, but it's the same for chlorine and fluorine as well. So, and benzene has delocalized pi electrons that spread all over all 6 carbon atoms in the ring structure. I bet you're getting bored of this by now. Alkenes have pi electrons localized above and below the 2 carbon atoms in the double bond. But it's important to appreciate this because it's that delocalization is what makes this happen. So if benzene has a low pi electron density than alkenes, so when a non-polar molecule such as bromine approaches the benzene ring, there is insufficient, keyword, insufficient pi electron density above and below any 2 carbon atoms to cause a polarization in the bromine molecule. Benzene is therefore resistant to reactions to non-polar halogens on its own. And the halogen carrier generates the bromine plus ion. I will write the equation for that in a bit, which is a more powerful electrophile as one electron has been removed, and it is able to attract the pi electron so the reaction can take place. So benzene goes to an intermediate state where the halogen carrier produces a Br plus ion, and that Br plus ion will attach to the bond where the hydrogen was, and the hydrogen goes there. So the hydrogen is knocked off, forms a H plus ion, uses one of the delocalized electrons, and bromine is where the hydrogen was. So that's it, really, about the reactivity of alkenes and benzene. If you want to flick back and play through it again, there's not really much to go through in this section other than to appreciate that benzene requires a more powerful electrophile, whereas alkenes only require the halogens themselves. It's important to remember that benzene needs to be completely stable in order for a stable intermediate to form, and then, well, sorry, an unstable intermediate to form, and then a stable product. Stable products always have the basic benzene ring. You cannot get a benzene ring that is broken. It will never ever be stable. This is always unstable. It's usually momentarily in that state. It can never ever permanently be in that state. So that's the important thing to take away from this. And next tutorial we'll go through phenols and why benzene is used in lots and lots of medicines as well. So this is a phenol. It's basically a benzene ring with an OH group attached. But we'll find out more about this mysterious phenol next tutorial. So thank you for watching. I hope you found this useful. Leave a comment in the comment section below, and thank you very much.